Welcome back to the channel. Today, we're diving into the backbone of the internet web servers. These often invisible machines are the engines behind every website you visit. So today, we'll explore the most popular web servers from their humble beginnings to 2024. Let's rewind to 1990, before smartphones and social media. Tim Berners-Lee at CERN developed the first web server using a Next computer. This single computer hosted the first website and introduced HTML, HTTP, and the first web browser, World Wide Web. It was like inventing the language, the postal system, and the mailbox all at once. This was the spark that ignited the internet revolution. The impact of this first web server was monumental, laying the foundation for the internet as we know it. As the web grew exponentially, it needed a more robust and reliable solution to handle the increasing traffic and complexity. Enter Apache, a groundbreaking web server that emerged in the mid-90s and quickly rose to dominance, becoming the backbone of the internet. Apache was open source, which meant it was freely available for anyone to use, modify, and distribute. This open nature democratized web hosting. This openness fostered a massive global community of developers who constantly collaborated to improve and enhance the server's capabilities. Apache's modular architecture was revolutionary, allowing developers to add or remove features as needed, making it highly customizable and adaptable. It could handle everything from small personal blogs to massive e-commerce sites, showcasing its incredible scalability and versatility. Apache's reliability and stability were legendary, with servers often running for months or even years without any issues, ensuring continuous uptime. This powerful, flexible, and reliable web server quickly became the go-to choice for webmasters and developers worldwide, cementing its place in history. Its open-source nature and the strong community support were key factors in its widespread adoption and enduring success. Apache played a pivotal role in the growth and development of the early internet, laying the foundation for the web as we know it today. Even today, Apache continues to influence modern web hosting, proving its lasting impact and importance in the digital world. While Apache was conquering the web, Microsoft launched Internet Information Services, IIS, in 1995. Microsoft had the resources, reach, and dominant Windows OS. IIS was tightly integrated with Windows Server, making it a natural choice for businesses. It offered a user-friendly interface and simplified administration. The rivalry between Apache and IIS pushed both to innovate and improve. Apache had the edge in flexibility, while IIS leveraged Microsoft's ecosystem. This competition ultimately benefited website owners and users. Despite Microsoft's efforts, Apache maintained its grip on the market. The open-source community behind Apache continued to innovate. Apache 2.0 brought significant performance improvements and better support for dynamic content. This was the era of the dot-com boom, and websites were becoming increasingly complex. Apache's widespread adoption by hosting providers reinforced its dominance. More websites using Apache meant more developers familiar with it. Apache had become synonymous with web servers. As the internet grew, so did the demands on web servers. Nginx, pronounced Nginx, entered the scene in the mid-2000s. Nginx was designed to handle high concurrency, managing many connections efficiently. Traditional web servers like Apache used a process-driven architecture which could strain resources. Nginx used an event-driven architecture, handling multiple connections within a single process. This made it incredibly efficient, especially for static content. Nginx's performance benefits quickly gained traction among high-traffic websites. Just as Nginx was shaking things up in the world of web servers, cloud computing came along, and transformed web servers even further. Cloud computing allowed websites to leverage the vast resources of tech giants like Amazon, Google, and Microsoft, making it easier to handle large amounts of traffic. Scalability became a breeze, as it was now about spinning up more virtual servers in the cloud with just a few clicks. Amazon Web Services, AWS, quickly became a major player in this space with their Elastic Compute Cloud, EC2 service. Users could rent virtual servers on demand, paying only for what they used, which was a game changer for businesses of all sizes. Not to be outdone, Google Cloud Platform, GCP, and Microsoft Azure also offered their own robust cloud computing platforms, each with unique features and benefits. The cloud became the new frontier for web servers, revolutionizing how we think about and manage web infrastructure. As websites evolved, so did the demand for speed and efficiency. Enter Lightspeed, a high-performance web server compatible with Apache. Lightspeed offered impressive speed improvements, especially for dynamic content. Its architecture was optimized for modern websites with interactive elements and real-time updates. Lightspeed's built-in caching capabilities further enhanced performance. Caching stored frequently accessed data in a readily accessible location. Lightspeed became an attractive option for website owners seeking a performance boost. A new paradigm emerged: serverless architecture. Serverless computing abstracts away the underlying server infrastructure from the developer. You write your code, deploy it, and let the platform handle the rest. It's incredibly scalable, automatically adjusting based on demand. It simplifies development, allowing you to focus on writing code. Serverless platforms like AWS Lambda, Google Cloud Functions, and Azure Functions gained popularity. This new approach offered a hassle-free way to build and deploy web applications. As websites became more complex, managing deployments became challenging. Kubernetes, an open-source container orchestration platform, brought order to the chaos. Containers are lightweight packages containing all necessary components of an application. Kubernetes automates the deployment, scaling, and management of containerized applications. It can spin up new containers, restart failed ones, and roll out updates without downtime. Kubernetes is crucial in modern web development, managing numerous microservices. It's become an essential tool for companies running large, complex web applications. We've seen web servers evolve from a single computer to complex systems. From the early days of simple HTML pages to today's dynamic, data-driven applications, the journey has been remarkable. Each step forward has brought new challenges and opportunities. What does the future hold? The landscape of web servers is ever-changing, and predicting the future is both exciting and daunting. The demand for speed, scalability, and efficiency will continue to grow. Users expect seamless experiences, and businesses must adapt to meet these expectations. Websites are becoming more data-intensive, and users expect lightning-fast loading times. This means that web servers must handle more data and deliver it faster than ever before. We'll see further advancements in serverless computing, allowing developers to focus on innovation. By offloading server management, developers can concentrate on creating better user experiences and more robust applications. Edge computing will play a bigger role, reducing latency and improving performance. By processing data closer to the user, edge computing can significantly enhance the speed and efficiency of web servers. AI and machine learning will influence web servers, optimizing performance and security. These technologies can predict traffic patterns, detect anomalies, and even prevent cyber threats before they happen. The world of web servers is about adaptation and innovation. Staying ahead means constantly evolving and embracing new technologies. As new technologies emerge, Web servers will continue to evolve, shaping the future of the internet. The journey is far from over, and the possibilities are endless. That was a journey. From a single Next computer to the cloud and serverless architectures, web servers have come a long way. Thanks for joining us on this tech deep dive. If you enjoyed this exploration, give this video a thumbs up and hit subscribe. We've got more deep dives, reviews, and tech explorations coming your way. Until next time, keep exploring, keep learning, and we'll see you in the next video.